Bismillahirrahmanirrahim. In the topic of shapes of the molecules of A-level chemistry, we use some simple techniques to find three-dimensional shape of the molecule and its bond angle. Let's start.
To understand shapes and angles of molecules, we must know what is the difference between a lone pair and bond pair of electrons in a molecule. Let's take example of ammonia. This is dot and cross diagram of ammonia. This is another structure of ammonia. So there are two types of electronic pairs. One is bond pair, which is present between the nitrogen and hydrogen in the bond. It is also called shared pair of electrons. While the second one is lone pair of electrons. It belongs to only nitrogen. It is unshared pair of electron. Let's talk about electronic cloud spread out of lone pair and bond pair. Bond pair occupies a lesser space because it is attracted by two nuclei, one of nitrogen and other is hydrogen. So it takes lesser space to exist, while the lone pair's electronic cloud is more spread out because it is only attracted by one nucleus, so it is more spread out. Now, bond pairs and lone pairs all repel each other because electrons have negative charge on them. So repulsion order is lone pair and lone pair. It is the maximum repulsion, and then lone pair and then bond pair and bond pair. So shapes of molecules and angles, they depend on the electron pair repulsion theory. And this theory states that pair of electrons around the central atom repel each other. So they need to adjust at a maximum distance from each other. So what is central atom and what is surrounding atom? So here in the molecule of ammonia, nitrogen is a central atom while hydrogens are surrounding atoms. So here the number of electrons present on the central atom is very important. So there are some important points of this theory. First point say that we must know how many electrons are there on the central atom, which we can see easily from its group number in the periodic table. And second point, we must know how many bonds are formed by the central atom, and bond making capacity of the central atom depends on the number of surrounding atoms. And remember that surrounding atoms always follow their normal bond making capacity. For example, hydrogen will make one bond, halogen will make one bond, oxygen makes two bonds, while nitrogen makes three bonds. So the next thing is, if there is no lone pair on the central atom, then the molecule will have a symmetrical shape. And what are the common symmetrical shapes? Let's discuss that. But before that, we must know we are going to discuss some hypothetical molecule and their original examples of the compounds. So in the hypothetical molecule, A is shown the central atom, while B shows surrounding atoms, and L shows lone pair. So first shape in our syllabus is AB2. AB2 means A central atom and 2B are surrounding atoms are here. So there are two bond pairs around the A and there is no lone pair, and two bond pairs repel each other and they adjust at a maximum distance from each other at an angle of 180, and the shape is linear here. The example is beryllium chloride BeCl2. Be belongs to group number 2, so it has two valence electrons and it shares one electron with each Cl atom. So in BeCl2, the shape is linear and angle is 180. So why it is called linear shape? Because this shape can lie in a line, so therefore it is called a linear shape. Next shape is AB3 molecule. So three B atoms are surrounding atoms which adjust at an angle of 120, and the shape is called trigonal planar because this shape has three corners, so therefore it is called a trigonal, and this shape lies in a plane, so therefore it is called planar. And example is AlCl3. So here we can also conclude that aluminium belongs to group number 3 and chlorine belongs to group number 7. So there are 3 electrons in the valence shell of chlorine, and each Cl shares 1 electron with central aluminium atom. So the conclusion is that all the atoms of group number 3, I mean all the elements of group number 3 and all the elements of group number 7, they form the similar shape trigonal planar. Next shape is AB4. There are 4 surrounding atoms with 4 shared pair of electrons around the central atom, and these 4 shared pair of electrons adjust at an angle of 109.5, and the shape is called tetrahedral. And example is CH4. So here we can conclude that all the elements of group number 4 do the same thing and have the same molecule with the hydrogen. For example, SiH4, because silicon also belongs to group number 4, S of carbon. And as hydrogen form 1 bond and all the halogen also form 1 bond, so same shape is expected between the elements of group number 4 and halogens as well. Next shape is AB5. So 3 bond pairs lie in a plane in the trigonal form, while 2 pairs, one is above the plane and one is below the plane, and therefore shape is called trigonal bipyramidal. And example is PCl5. So phosphorus also form the same shape of the molecule with other halogens, and similarly the other lower group members of phosphorus, just like arsenic, also form the same trigonal planar bipyramidal shape with halogens. Next is AB6. So these are 6 bond pairs around the central atom. 4 surrounding atoms, they exist in a plane in the form of square, while one above the plane and the second one below the plane. So the shape is square bipyramidal. An example is SF6. So sulfur forms the same shape with other halogens, and other lower members of group number 6, because sulfur belongs to group number 6, form the same shape with the halogens. For example, selenium F6 or tellurium F6 form the same shape. Next, if there is one or more lone pair at the central atom, then shape is a little bit distorted. For example, the first case in our syllabus is AB3L. So here 3 bond pairs and 1 lone pair. So it is a distorted shape of tetrahedral molecule AB4. So here the structure was tetrahedral, but at one corner there is a lone pair, and lone pair repel the bond pairs with a greater extent. So therefore bond angle is decreased from 109 to almost 107. An example is ammonia, and its shape is like pyramid, so therefore it's called a pyramidal shape. Next, AB2L2. So there are 2 lone pairs. So it is again a distorted tetrahedral shape where 2 lone pairs are there at 2 corners of tetrahedral. So there is a more decrease of the angle, and it is 104. And this shape name is bent or V-shaped. And example is water. The next thing we need to remember is double or triple bond plays the same role as that of single bond in the shape determination. For example, CO2, carbon is in the center and 2 oxygen on the surrounding atoms, and there is a double bond between carbon and oxygen. So this double bond also plays the same role as the single bond. So the shape is linear with an angle of 180. And in HCN, there is 1 single bond between carbon and hydrogen, and there is 1 triple bond between carbon and nitrogen, and triple bond again considered as a single bond in shape determination. So the shape will be again linear, and angle is 180. The next shape is SO3. There are 3 double bonds around the sulfur, and shape is trigonal planar with an angle of 120. You can see all the details from my notes of chemical bonding, and here at the page number 10 there's topic of shapes of molecules and bond angles. So here all the important points are given with the shapes of the molecules, and I added preferably those molecules and their shapes with angles in my notes which commonly or repeatedly appear in exam papers. After preparing the topic, you can do practice of questions from my topical compilation of chemical bonding. For example, here, question number 2 is related to shapes of the molecules. Here we need to write shape of the molecule and its angle. For example, the first one is carbon dioxide and its shape. We have learned that it is this one. Shape name is linear and angle 180. Next, ammonia. Ammonia's shape is this is, and due to the lone pair of the nitrogen, shape name is pyramidal. And bond angle is 107.5 degree, or you may also write 107 degree. Both values are acceptable. Next is water molecule. Its shape is this, with two lone pair on oxygen. Shape name is bent or V shape. Angle is 104.5 degree or 104 degree. And the next question is again related to shape of the molecules, and we need to write the shape and bond angle of gallium chloride. Gallium belongs to group number 3, and it is a halogen belong to group number 7, and we have learned that its shape is trigonal planar. And bond angle is 120.
Now I hope you can find shape and bond angle of any covalent compound. Share with others.